टेक्नोलॉजी ना जब भी आती है तो लोग ही फट जाती है।
कि भारत के युवा पढ़ाई के साथ ही स्किल में भी उतने ही दक्ष हों।
Welcome back, friends, to Skill Raptor, and I am your host, Atharva. Today, we are going to see a very interesting open source tool which can be used to actually simulate a whole chemistry lab. Yes, you heard it right. You might have seen industries and even institutions, they have huge chemical laboratory setups in which there are so many equipments, glasswares, chemicals, there are acid bases, and you perform certain experiments on that. Now, it's not possible in everyday life to have such kind of a facility. So how to do that sitting on your laptop, and that absolutely for free. So we are going to look at a software. Please kindly watch this video till end, because what we are going to do in this video, firstly I will show you the software, where it is, how to download it. Then I will be introducing you with the interface of that software, how to you basically use it, how to navigate through it. And thirdly, I will be going to show you a simple example where we will do some theoretical calculation, a simple theoretical calculation, and we will try to simulate the same in the software to see the result. Now, who can be the beneficiary of this? Even industries, chemists, then industry specialists, even CXOs who want to cross-check certain calculations, who want to cross-check certain chemistries which you perform, and also students, 11, 12 students, you can actually perform simple problems in on this software uh, uh, from a JE advanced kind of perspective. And overall, this is a very fun software and everybody can use it. You can do certain interesting things. I will show you shortly. Now let us see how to first download this software. Now just type chemical collective virtual labs. Press enter. Now you can see the window has opened, and click on the first link, resource type virtual labs chem collective. Just click on this. When you click on this, you will land on a page which will show you different types of stoichiometry, thermochemistry, equilibrium. These are basically different things which you can actually do on this. It's a very interesting website I found, and there are so many different things which actually you can do on. They have their online setup as well, so you can just go to their online setup and start performing your experiments. When you click on certain link, a window will open, and this is a virtual lab. So this is an online virtual lab, but they also have a offline which we will be downloading. Just click on the stoichiometry and go to glucose dilution problem, the glucose dilution problem, and click on get info. When you click on get info, you will see download offline version. Just click on that. After you click, you will have different options to download this software. First is download Visual Virtual Lab for Windows, and another one is for Windows, but there are different languages. And then on the downward side, the downward most is download Virtual Lab for Mac. Now click on the download Virtual Lab for Windows 10, and also note that you may need to install this small plugin, Java plugin for Virtual Lab to run, in case you don't have that. So it's a very simple installation, nothing much in that. Just download, click on the download button, and this will start downloading. There will be a zip folder. Now you can see there is a zip folder here, and just right click on it and open, just extract. Just click on the extract button and it will start extracting. Once you are done with extracting, just open this and you will see application VLab. just double click on that. So here I am on the interface of virtual chemistry lab. You can see the interface is actually divided into three parts. The leftmost is kind of a shelf where you have different chemicals, liquids, acids, they are kept. You can see distilled water, then stock solutions. There are different stock solutions which are available in different concentrations. Strong acids, conjugates, weak bases, and even indicators. You may well appreciate that while in 11th, 12th standard, we many a times we used phenolphthalein. So phenolphthalein, methyl red, methyl orange. Then there are certain solids which is NaCl here, common salt. And if you click on the left icon, it will expand the menu. So the leftmost is kind of a shelf where your glasswares and chemicals are kept. On the pane, you can see there are beakers, then graduated cylinders, pipettes of different volume are kept. So this is kind of a shelf leftmost. We will see how to use them on the workbench. Now the middle portion, which is a big square, you can see it's a workbench. You can consider this as a table or uh, the floor where you actually perform experiments. So here, whatever we select from our interface on the left side, which are chemicals and glasswares, the things will pop up here. And rightmost side is the output of whatever we do. So here are some parameters which are shown. The bottommost is pH meter. Then here, the white strip is actually the temperature. I will show you how it shows. And then whatever liquid you select, it will show you different properties: aqueous properties, solid properties, and spectrophotometer, the kind of absorbance which different liquid shows. Uh, okay, so this is the simple interface, and top side you have file, then tools, same things, glasswares, instruments. In instruments you have Bunsen burner, weighing boat, and scale. Viewers, so these are the different views which we have seen: pH meter, thermometer, species viewer, and solution properties. Then you can also select the transfer. So precise transfer, then there is significant figure transfer and realistic transfer. So currently it is on precise transfer. That's what we need. And view, you can change the view. It is a bit dull view, I understand, because it's offline software. I am changing it to emerald. It will look little better. Okay. So the green portion which you are seeing in between is actually your workbench. Now let me show you how you actually drag and drop. Just click on the distilled water on top side and just drag it. So you will see the distilled water appeared here. And if you right click, you will see different options: set as a source, set as a recipient, even thermal properties. Just click on it. So it shows temperature. You can actually set the temperature. So say for example 35 degrees Celsius. Click OK. On left hand side, on right hand side, you will see the temperature window is being shown here. So the temperature is continuously dropping because there is a cooling mm, that is happening. So it actually simulates the real environment. And also if you click, it is showing you the pH. The pH is around 7. Because of temperature there is certain variation which it is showing. Now let me just bring it back to 25. 25. Okay, now it will show you 7 pH. Here you see there are properties, aqueous properties. In aqueous properties there are two species which are present in the water, that is H plus and OH negative, and the concentration is shown here in molarity. You can change it in grams, moles, or molarity. You have solid, so there is no solid present, that's why it's not showing anything. And spectrophotometer, since it's a pure water, what we consider here is it's a distilled water, so there is no absorbance as expected. Now let me take a 3 molar HCl and I will just drag and drop it here. And maybe let me just take a beaker, select a beaker. I'm taking a 600 ml beaker, so it will show you here. Now to pour something, you have to just take it above this, just drag it. So now it will show, it will give you this kind of a orientation, and on bottom side here it is a transfer amount written in ml on the bottom. Now if you type say 12 ml and press enter, you can see there is something which is filled up here. Now similarly, just drag and drop, take it away, and it will become normal. Now you can also pour from this flask to this beaker. Similarly, you can do this. And if you want to pour distilled water, then just drag and drop distilled water above it, and you can pour. On bottom side, just write 200 ml and press enter, and it is showing you a error. The reason is the recipient flask will overflow. The size of this flask is not sufficient to get that water. So you can see, in a way, it is actually giving you a feel of a real time handling of equipment, though everything is not certainly the real, but I think 90-95% is definitely being simulated here. If you want to remove this from workbench, just click on it and press enter and press delete, and it will remove. Just click on it and press delete. Now my workbench is clear. Now this is the basic interface, and now we will see how actually we can simulate a certain experiment. Firstly, I will show you the theoretically what we want to do, and then I will do it here itself. Okay. Now so this is a simple problem we are trying to simulate here. So we have an acid of 3 molar concentration. It's a hydrochloric acid, HCl. The quantity is 100 ml, and we have a water, a distilled water we have 2000 ml, that is 2 liter, and using this we want to make a 500 ml of a solution which is having a 2.5 pH. This means that I want to add some amount of acid into some water so that the total of that solution is a 500 ml, a 2.5 pH solution. So how to do that? So here first thing to note is 2.5 pH corresponds to certain concentration of H plus. Now how to find that concentration using a pH value? I have shown it in my previous video lecture. I will be giving the link in the description so you can go back and watch it. Another thing is we want to find out how much acid should be added in how much quantity of water so that I get a 500 ml of a 2.5 pH. Now how to do that? Now it's very simple. This I have explained in my previous video. Now you want to find out acid, that is A. A is a quantity of this solution of 100 ml which is having a 3 moles, that is 3 moles per liter, 3 molar, and I will be adding this in water. So here 0 is the concentration of H plus, which is not actually 0 because there is some H plus always in water, but it is in the order of 10 to the power minus 7. So that's like very small, so that's why I am neglecting it. That should be equal to 0.0031 moles per liter. Again, how to convert 2.5 pH in 500 ml, and to find this is by the way 0.0031 is the concentration of H plus into 0.5. So this equation I will be solving to find A and W. And by the way, A plus W, which is the quantity of acid total plus quantity of water total, should give me 500 ml. So I want to find A and W, which will solve my problem. Now after you solve this, you will get 0.00051 liter, that is nothing but 0.51 ml of acid. So I will have to take 0.51 ml of acid solution from this 100 ml, and by a simple logic you can appreciate that if A plus W is 500 ml, then water which needs to be taken is 499.49 ml. Okay, so let us now check it whether our calculations are true or not. So I have a 3 molar HCl stock solution in my workbench and water, distilled water, and now I want to make a 500 ml 2.5 pH. Now let us go back to our workbench, the virtual tool, virtual lab, and try to make this solution. Okay, now I am on my workbench. Now I want to select certain things. First is distilled water. I will just drag and drop. This is my distilled water. I will need a stock solution. So you can see the second option in the strong acids is 3 molar HCl. I will drag and drop, and I want to have a beaker which is at least 600 ml, because I want to make a 500 ml of 2.5 pH. Now in this beaker I will be making this solution. So as per our calculation, I need to add 0.51 ml in the beaker. So I have dragged and drop, and I will just type 0.51 ml, press enter. You can see some acid is being dropped here. Okay, now I want to add some distilled water here. So I am dragging and dropping it near to this, and in the bottom space I will type 499.49, I guess, and press enter. Now my solution is made. This is a total 500 ml. If I will click, you can see on right side it is 500 ml in volume. Now I want to check if we have achieved a 2.5 pH or not. So on bottom side you can see it is 2.51. The reason is we are taking decimals up to 2 places only. If you take more decimals, then you will have a better accuracy. So this is how we made a solution. So our theoretical calculations were correct, and this is how we can verify. This is a small example. There are so many other things which we can do on this software, which I will be explaining you later. You can also comment on this video if you liked it, so we will be able to put more certain videos in detail. So thank you very much, and please kindly like, subscribe, comment, and also share it with your friends, families, and whoever you think may be benefited out of it. Thank you very much.